Hello everyone, today we're going to be working on solving radical equations. Our goal for today is we're going to learn how to solve equations that have both integer exponents and rational exponents. So looking at this first one here, we want to solve these radical equations. When you're solving a radical equation, you're always going to be trying to get the radical by itself and then use an exponent to get rid of it. So if we look here, this cube root is by itself. There's nothing outside of it on the same side that's affecting it. So once it's by itself, what we can do is we want to do the opposite. So the opposite of doing a cube root would be raising to the third power. So we're going to raise both sides to the third power. And so here the cube root and the third power will cancel out. So we're left with 2x minus 9. And then here we have 2 raised to the third, which is 8. And then once we've done that, we have a really simple linear equation to solve. So we're going to add 9 to both sides. So we get 2x equals 17. And then divide by 2. And we get x equals 17 over 2. For the next one, like I said before, we want to get the radical by itself. In this case, there's a 2 in front, and since it's a big 2, that means it's multiplying. It's not the number with the root. So we need to divide by 2 first. So we get the square root of x plus 1 equals 2. And so then we need to, since it's a square root, we need to raise both sides to the second power, because squaring and square rooting are opposites. So we get x plus 1 equals 4. And if we subtract 1 from both sides, we get that x equals 3. Alright, now let's look at the next section here, solving with rational exponents. So when we have rational exponents, we're going to be trying to get whatever's being raised to that power by itself first, and then I'll show you how to get rid of that. So if we look here, the 2x is being raised to the 3/4, so we need to get rid of this 2. So I'm going to subtract 2 from both sides. So we've got 2x to the 3/4 equals 8. Now, in order to get rid of that exponent of 3/4, what we can do is raise both sides to the reciprocal of that. Because remember, when we raise a power to a power, you multiply them. And if we multiply 3/4 by 4/3, so 3/4 times 4/3, that equals 12 over 12, which is just 1. And so then if we just have 2x to the first power, that's just 2x. So we've gotten rid of that exponent. So I'm going to raise both sides to the 4/3. So we have 2x equals, now we want to simplify this 8 to the 4/3. Remember that 8 is the same as 2 to the 3rd, so I can replace 8 with 2 to the 3rd. So if we've got 2 to the 3rd to the 4/3, remember when we have a power to a power, you multiply them. So we have 3 times 4/3, which is 12/3, which is just 4. So really, that's 2 to the 4th, and then 2 to the 4th is 16. Alright, so we simplified 8 to the 4/3 by changing 8 to be 2 to the 3rd because those are equivalent. Then we simplified because we had a power to a power, we multiplied them. So that made the exponent just be 4, and 2 to the 4th is 16. Now all we have to do is divide by 2. So we get that x equals 8. Alright, looking at the next one. There's nothing not being raised to the 3/4, so we are going to go ahead and right away raise both sides to the 4/3. And so we're going to end up with x plus 2. Now again, we can simplify this. If you notice, we actually have the same thing on the right side here as we did over here. But I'm going to go through it one more time because seeing it a second time might help some of you understand. So we have 8 raised to the 4/3. We know that 8 is 2 to the 3rd, so I can replace 8 with 2 to the 3rd. Since we have a power to a power, we're going to multiply. So 3 times 4/3 is going to simplify to just be 4, and 2 to the 4th is 16. Then all we need to do is subtract 2, and we get x equals 14. Alright, now one last type of problem here. So now we've got some integer exponents we're going to deal with. We still want to follow the same idea where you have to get whatever's being raised to the power by itself first, and then we're going to take a root of both sides. So here, only the x is being raised to the 4th power, so we have to get rid of that too. So I'm going to start by dividing by 2 on both sides. So we have x to the 4th equals 81. Now the opposite of the 4th power is the 4th root. So we're going to do the 4th root of both sides. So we get x equals. Now we want to try to break down 81. So 81 is 9 times 9, which is 3 times 3, which is 3 times 3. Since it's a 4th root, we're looking for groups of 4. So I have 4 3s here. So I can circle 1, cross 3 out. Then there's no leftovers. Since there's no leftovers, that means the 4th root of 81 is 3. And so then that is our final answer. Alright, looking at this one, again, here we're looking to get whatever is being raised to the 3rd power by itself. So that would be the whole parentheses in this case. And then there's nothing else on that side. So in this one, we can go ahead and just do the cube root right off the bat. So we have x minus 2 equals the cube root of 10, because I know 10 is not going to break down any farther. Then I can add 2 to both sides, and we get x equals 2 plus the cube root of 10. Now I just want to jump back to the one before real quick. One thing I forgot to mention is whenever you take an even root, you always have to put a plus or minus in front of your answer. So that's only for even roots. So let's jot down a note about that. Even roots, which we've learned before because we did that way back at the beginning of the semester with when we took square roots, we would always put a plus or minus in front. The same rule applies if you take a 4th root or a 6th root or an 8th root, etc. So even roots, always put plus or minus in front. We don't have to do that for the second one because 3 is an odd number, so that's an odd root. So I just wanted to mention that, and then that's all that I have for you today. So make sure if you have any questions, you jot those down, and good luck.